Okay, my name is Daniel Polani. I am from the University of Hertfordshire, from the Adaptive Systems Research Group. And the research I am presenting here is about measuring or suggesting a measure for self-organization. Self-organization is an interesting notion, and the problem is that often it is approached in the field of artificial life by saying, I see it, I know when I see it, which is unfortunately putting the human in the loop. So what we are trying to do here is to define a notion of self-organization which is objective in a way, where we can say exactly how to measure it in a given system. So the basic idea is to say we're studying the self-organization of a system which is kind of characterized, commonly known as a self-organizing system. It's also called self-organizing map, namely Cahonen self-organizing map. It's just a toy model. We can use any other system to apply these methods on. And basically the idea is to use an information theoretic measure, kind of integration information, or it's called also intrinsic information or integration, as used by Tononi, Sporns and Edelman, to measure the self-organization of a system by saying, okay, I have the system and I have also to specify an observer which is a particular way of looking to the system, a particular way of separating sub-features of the system and comparing how these sub-features talk to each other, if you like, during the process that the system undergoes. So given a dynamical system, you can look at this intrinsic information and how it develops, and if it grows, you can then say the system is self-organizing. Self-organization, therefore, is reflected in the fact that the different filters that you use to look at the system talk to each other more and more during the development of the system, while they will be independent at the beginning. That's basically the idea of the approach.